Hi, everyone. Can you hear me? A couple more people coming in. Okay. Did you have a good lunch? It was really tasty for me. Um, but enough of that. Let's move on to really heavy stuff. Today, I'll be talking about cognitive science and what we can learn from it as designers and developers. I really try to cast a wide net so that both developers and designers can see how some of the theories from cognitive science could influence the way they work. My name is Magdalena Maglicic. I'm definitely not from New York, although my company does have offices there. I'm a React developer at Five. Five is originally from Croatia, from Zagreb. We have a big office there. There's more than 180 of us right now. And we're developers, designers, data scientists, managers. And what we try to do is build really good products for our clients. The natural question is, why am I talking about cognitive science if I'm a React developer? Like, it doesn't really overlap, does it? But in reality, the way we do our projects at Five is that even the developers are really engulfed in this process of building profitable products for our clients, and we are instructed to think about how the end product will be used, and if we have any suggestions, how to improve it. So what is cognitive science? Cognitive science is the study of the mind and its processes. You can also say that it's a study of intelligence. Now, intelligence can be human intelligence, animal intelligence, or even machine intelligence. It answers questions like, how do people process information? That is a somewhat easy question to answer with some of the models that we have nowadays, but also hard questions like, what is consciousness? And that is something that we still haven't been able to replicate in machines, in artificial intelligence. Now, the questions about how humans think and about human mind have been around since the first philosophers, like from Plato and Aristotle. And each generation, each era had its own answers to the question. For example, when the machines were invented, we had the first gears and shifts. People imagined that in our own brains we had some gears moving about and creating the behavior that we see. And in the 1940s, somewhere around 1940s, the first computers have emerged. And it really made a difference in the way how people started to think about other things as well. We started to think that other complex systems like our brain function just like computers. And then we saw something that's called cognitive revolution in the 1950s, where very notable linguists like Noam Chomsky, neuroscientists, cognitive scientists, have started to think about the brain as a computer. So the main question was, how do we understand the brain? Is it just a pile of neurons firing chemical balances, chemical reactions, or is it something else? We started to think of the brain as information processing unit, basically, that has some input and processes the information with some algorithm or through some function, and then has an output that we can see. And that's when cognitive science really became a formal field of study. It's an interdisciplinary study, so it relies on 6 main fields of study: philosophy, linguistics, anthropology, neuroscience, computer science, and psychology. It is very complex because the questions are also very complex and cannot be answered within just one field of study. Besides these 6 main ones, we have also some tangential fields of study that have contributed to the theory of cognitive science or have benefited from some of the findings. In this talk, I will touch on linguistics, psychology, design, computer science, which is very natural for us as digital workers in the digital field, artificial intelligence, and a little bit about neuroscience. Let's start with psychology. Psychology has really benefited from the cognitive revolution because in the 1950s, we stopped experimenting with, people and groups of people in a way that we're just observing the behavior. We really started to think about the internal processes that go on. So psychology is interested in the same kind of subjects that cognitive science is: cognition, attention, memory, intelligence, but it approaches the whole matter through a more experimental, hands-on feedback approach. It doesn't really do abstract theories. It actually sits down people and asks them questions, and on the basis of the answers, draws conclusions. So that is a very similar process to how UX works, user experience, right? The methods used in cognitive psychology are very similar to the ones that modern user experience designers are using. I am always puzzled on why more psychologists are not going into the field of UX design. It's usually the graphic designers decide to switch from UI to UX. But actually the knowledge taken from cognitive psychology would be very useful. And also you will see later on that just the visual information that we get from our applications are not going to be enough, or they're not going to be the only source of information in the future. What are some useful findings in the field of cognitive psychology? You might have heard of Gestalt theory. It's very old, 1920s, basically 7 principles that basically describe how the human brain finds patterns in the chaos of information that it gets, how it's trying to find meaning in what it sees. So these principles are very basic for designers. When they start out, those are basically the ones that they have to learn to do anything. But also, the result of these principles is also seen for us developers in our work. Now tell me, is this pretty code? No? It's not. And it's not just because it's jQuery. It's also because it's just a block of text which we as humans cannot cannot process very easily. We need the visual cues that tells us, like, this is one block and this block has a separate meaning than the other one. We need the space. We need something visual to help us process information. So a lot of user experience designers or thinkers in the 20th century have written books trying to explain all this, or trying to kind of make it more obvious to modern designers how to use these principles. Don Norman, that wrote the previous 2 books, he had a theory, which is like very cognitive science type theory, that says when humans interact with computers, they go through 3 levels of processing the information that they're getting. The first one is visceral. Visceral is the low level. It's just the intuitive, the first impression that you get. You're not even able to process what you're saying, but you do still have a positive, negative, or a mixed feeling about what you're seeing on the screen. Behavioral is the one that user experience designers deal with the most, because that's the stage when the user actually is going through the application, interacting with the software, and trying to figure out is what is going on something that the user expects? Is it in line with the social kind of predisposition that or knowledge that they have and what they expect? The reflective level is the level where the user is accessing their memory, trying to figure out whether or not they liked the application that they used before, and then if they did, they go back to it and use it again. the point here is that designers, or to make a good digital product, you really have to be able to make good design on all three levels. You have to be able to make the user like all three phases of the processing of the information. So one finding in cognitive psychology is that people people use only 50 milliseconds to decide whether or not they like something. So that means that web designers only have a very short time slot of 50 milliseconds to make the first impression. And that finding can be very easily translated into a very to a direct design decision that we make. And on digital screens is to put the most important information above the fold, of course. And something that it's intuitive, but it has a very solid cognitive science theory behind it, why that is. Also, there's this notion that we have a very limited short-term memory. We can only hold 7 plus or minus 2 pieces of information in our memory, which means that we as humans, we get very easily cognitively overloaded with information. And as designers, we need to make sure that doesn't happen to the user, and that we only serve the information that is critically needed. Google is the most famous example of that, where they got rid of all the clutter and just have that one function, which makes easy to make that decision to use the search. This is another example, and it's, out of all of these, it's my favorite because it's an example of how you use a finding or a term in cognitive psychology to actually design software, not user interfaces per se, or use it as a design decision, but when you're actually writing a plugin for the software, you think about how the end result will look like. So this is just noticeable difference is a term in psychology that says that defines the amount of how much something has to change for you to actually notice it change more than 50% of the time, which translated into React fiber scheduler software that said, okay, we can do lazy loading on the site, and as soon as we get information for pieces of content on the web page, we can show it. And intuitively, that would be great. As soon as you have something, just show it on the screen, right? But actually, in reality, users perceive that performance as being pretty sluggish compared to if you just wait for all the content to load and then show it all on screen. So there's a little difference there in the wait time, but the perceived performance of the users is actually better in the second example. Okay, more on that and cognitive biases and user experience in the next talk. Let's move on to other areas of cognitive science. Linguistics. Linguistics has been in cognitive science from the very beginning. It was always, in the cognitive revolution, it was linguistics, artificial intelligence, and psychology. And actually, the biggest driver of cognitive revolution was artificial intelligence. We see it as something very new, but all the major theory about artificial intelligence has been developed back in the day, in the 1970s mostly. But linguistics also played a major role. So today we have something called natural language processing, which is a subfield of linguistics that deals with, it is concerned with the communication between human and computer in a natural human language. And the major technology behind it is machine learning. And we'll talk about it a little bit later, and we also heard about it before. Machine learning is big today. This is some kind of a technical process that you might understand about what it takes to process the natural language of humans and also synthesize it back or generate it back. So we have voice pickup that translates into, recognizes, and then translates into text. We then have to understand the text, draw some meaning from it or data, and then back into a loop from that data or meaning we can generate language and synthesize speech. So today, voice user interfaces have been everywhere, really. It seems like every device that you have, you can talk to it today, or you can give it an order. And we will see a rise of this definitely in the future, because the technology is there so that we don't always have to have the graphical user interface. We can also talk to the computer, which poses a whole new level of demands on the user experience designer, because now you have to learn how to design devices like these, software like this, so that it behaves like human. The one thing that I'm very excited about the voice user interfaces is that it's gonna do wonders for accessibility, especially for visually impaired people. I have had the opportunity to watch a visually impaired person interact with the computer, browse the internet, and it was really embarrassing. Not for that person, but for me as a front-end developer, because basically the technology they have right now is a screen reader that reads through the technical nitty-gritty of the code of the website and tries to just spill it out for you, and you have to decide how to navigate it, which is something that we as developers don't really think about a lot, or it's never high on our priority list, but voice user interfaces will change all that, and it will be much better in the future. At Phi, we had this project 2 years ago. We had to design and develop a chatbot for Marriott, the hotel chain giant. And the main question was how to make the bot behave more human, because we knew the technology, the natural language processing, but then the designer had to make some decisions to make the bot just seem less artificial. We had some constraints there. We had to make sure that the user can actually input anything. So a lot of the chatbots today have a very linear way of guiding the conversation, where you are basically picking one or the other option from a predefined set of options. But we had to make sure that the user really can input anything, and then we can guide the conversation in any direction. We had to make sure that we have multiple contexts and topic flows. So if you're in one topic flow, you say a keyword from another topic, or you're expressing intent that you want to talk about something else with the chatbot, we have to make sure that you can switch lanes and switch topics. So for this, we used a service called Google's Dialogflow API. It has natural language processing. It has machine learning in its back end. And that is something that we use. We did not develop our own models or do machine learning, but we did use artificial intelligence. So on top of all of that, we had this layer of nuances of the sentiment analysis, which is basically telling us how the user right now feels going through that chatbot, communicating with the chatbot. Are they happy? Are they sad? Are they just want to quit? And that is something that also gave us some information of how to guide the user and if we did something wrong. This is a very short. Does it work? No, it doesn't. Oh, because it's a PDF. Oh. Okay. Anyway, this is how the bot looks like. It does offer you some predefined answers, but you can always type in something else, and you can always, and the Google intelligence in the background basically is picking out keywords and trying to find out the intent and the category of what the user is saying. Okay, so that was basically linguistics combined with computer science, but computer science, where it overlaps with cognitive science, is the field of artificial intelligence. And what artificial intelligence is trying to make computers act and behave more like people. People are really good at reasoning, memory, language, face recognition. We're really good at learning new stuff. We're creative, We have that level of consciousness where we know that we are aware of our own processes. And computers in the beginning, they were good at calculations, and they were good at, memorizing data. Their memory is not the same as ours. If it's better or worse, that's, up for debate. But it was really good at these things. And now, today, we have managed to teach our computers to speak our language, to recognize faces, which is really important to us because we're so naturally good at it. And actually, we taught computers how to teach themselves, how to make decisions without us intervening. We're still working on this, of course, and there's no unified theory how to do it best, but we're making some progress. So today, the result is a lot of apps or a lot of services that you as developers or designers can use in your applications or can suggest to clients that would be the best solution to their problem. Some of them we've seen chatbots, personalized UI, voice-based interactions. Sites like Amazon, they have recommendations for shopping items based on what they know about you, about your preference. That is, on one hand, very scary, but on the other hand, pretty useful. So there's that, decision to make in artificial intelligence, how useful it's going to be. So artificial intelligence is not really going away anywhere because the theory has been here since the middle of last century, and now we finally have the processing power and the amount of data that we need to actually have some artificial intelligence practically useful for us as developers. But machine learning is really complicated. I mean, there are so many ways to go about it. And should you, as developers, maybe the next step in your career should be learning, machine learning about it? I would say that not necessarily. Although artificial intelligence and anything machine learning oriented will come up more and more in your day-to-day work. More and more clients will ask for features that use machine learning. You don't actually have to go into the complicated math and algorithms of it unless you're really interested in it, because it is a fascinating and a growing field. What I think that will happen in my career is the use of machine learning as a service. Because all the big shots, Google, Amazon, they have the data, they have the processing power, and they will offer normal developers or businesses will offer the service or the APIs to use that in our work. So this was an interesting article that I saw the other day, and it was just right in the right time. On the main engineering faculty in Zagreb, a center for artificial intelligence is opening up, and they will offer businesses the service of calculating the machine learning, the artificial intelligence for everybody that cannot have a dedicated team to do that. So this is the future. These are hints of the future, and we're actually late on the game in Croatia. This has been going on for quite a while in other countries, but you as designers and developers can expect to see more and more of this in your work. That's basically it. Thank you.
Is there a question maybe? Thank you. There is a question. There's quite a few questions. We'll give you the mic, and I'm back up.
Hi, excellent speech.
Thank you.
I was wondering, what do you think about centralization of services like Google, Microsoft, or Amazon when they took over all the data and service? Can that be potentially dangerous for the rest of us? If they handle all the information or all the data.
So it will be very important in the future who has the data. So who is the owner of the data? Who do you let have your to let access to your data? What are the privacy issues? That is one of the main things. I mean, again, just like with Amazon, having something recommended to you seems fun, great, but there's a whole line of privacy issues behind that functionality. It would be great that we as business and developers think about not just how cool it is to use this technology, or maybe that just our client is profiting from it, but also how it affects the end user, how it affects the whole picture of the artificial intelligence progress in the future. Yeah, make sure that we don't make critical mistakes now, so that we, regret it later with our data.
Okay, thank you. There was another question here.
Hi.
Hi.
I was wondering, does Five employ like behavioral psychologists, and do you guys rely on the common principles like the ones you mentioned when designing your apps and experiences, or have you had any internal breakthroughs, and do you document them? How does that work? Thanks.
So I don't really kind of keep count of what the design team at our company internally is working on, what kind of advances they're doing, but our lead designer was a trained psychologist. So our lead designer was a trained psychologist that turned into a designer and then a user experience designer. And you can only imagine, I mean, he was not just brilliant, but also the knowledge that he got from psychology had direct impact on how well his design really, was, and how the end user was satisfied with it. So yeah, we do have examples, and I'm very surprised that there are not more examples like that, where psychologists are saying, okay, this is really the field where I can take my knowledge and make a change.
Okay, thank you.
Okay.
I'm sure Magdalena is available for chat.
Yep.
And will you be at the after party? Yes, definitely.
Yes.
So grab a beer and ask her around 1 a.m. What do you think about behavioral scientists? Don't do that. I mean, give it a go, of course.